Okay, so inshallah we will continue where we stopped the other day, and over the last few lectures we have been talking about design patterns, and we have gone through the creation design patterns, and we are going through the second category of the design patterns, which are the structural design patterns. So inshallah we'll try to complete the structural design pattern today, and then inshallah we'll do an activity on one of the structural design patterns as well, just to do a bit of exercise on how we can use these design patterns for another example. So just to refresh the memory, we have again, there are many others, by the way. I was just looking at some examples which I believe are popular in the market. So we had a look at the facade one, basically, which allows you to create a interface class or a facade class, which basically helps you structure the connections or communications between the classes within a subsystem or a package with other subsystems or other packages. And we have something called decorator. Decorator design pattern was all idea was that you structurally make such a change that the original functionality does not change, but you can add new functionality without really changing the structure of the original one. Like in the example we saw the other day, we can have normal drawing of the circles, and then we can have special case where you can draw a red circle or something like this to add new functionality. Now today, inshallah, we'll look at the remaining three examples I have selected for structural design patterns: adapter. Then we'll look at, inshallah, on proxy, and towards the end, inshallah, we'll look at something called bridge. Ready to go?
Yes.
Yes.
Great. Everybody's comfortable with these two ones, the ones we covered on Tuesday?
Yes.
Okay, great. Thank you.
Yes. Yes.
So the adapter design pattern, what it does, the adapter design pattern actually acts like a bridge between two incompatible interfaces, and this is the key point here. It's a design pattern which will act like a bridge between two incompatible interfaces, and it's structural in nature, or this design pattern is structural in nature because of the reason that this allows you to combine the capabilities of two independent interfaces. So again, the key point here is that maybe you will need to adapt, or you need to connect or let these two incompatible packages or subsystems or components or plugins to work together. Hence, you want to create a bridge between them. Or sometimes they are independent ones and you want to now let them combine them together to achieve a certain functionality. And the key point in your adapter design pattern is that it helps you interface flexibility with external functionalities which are independent from each other, or they are separate functionalities, or they are separate components or separate plugins, right? So the whole idea actually just boils down to this concept to create a bridge between two either incompatible interfaces or between two independent interfaces or subsystems or plugins. As has been the case with all the other structural design patterns we have covered so far, like in the case of facade or decorator, and so also in adapter we create a single class, which is the adapter class, and it will be responsible to join the functionalities of either independent or incompatible interfaces. So we'll be creating a single adapter file or adapter class, and which will allow us to join these to either independent subsystems, plugins, components, interfaces, whatever you like to call them, or incompatible. And I think the examples are, we can visualize this with the help of a more like a hardware examples. I'm pretty sure all of us have used adapters pretty much every time we have used different hardwares. I'm pretty sure you must have used adapters like conversion of a VGA into a USB, or uh, uh, one memory card incompatible with another laptop, or maybe using HDMI to VGA converters and all those kind of stuff, right? Isn't it?
Yes.
Yes,
Yes,
we
and,
use
and
it.
yes, exactly. And they're all adapters, right? They help you adapt either independent hardware or incompatible hardware. Like they don't really fit. For example, you don't have a HDMI, output in your hardware. For example, you have an older one, so you maybe have a VGA to an HDMI converter, or it could be that you want to interface to independent hardwares. So these adapters, so these adapter concept is exactly the same in on our side, on a software side, on a class level. Basically, what you're trying to do is you're trying to join all these functionalities either coming from independent or incompatible interfaces. So let's look at an example, inshallah. This will help us better understand this design pattern. I'll let you guys have a quick look at this diagram, and then I'll look for some volunteers to help us initially explain what comes to your mind by looking at this diagram. So kindly take a moment, and then I'll look for one or two volunteers to help me explain this. Okay. Anybody would like to go ahead and see what's happening here in this example?
it's really not clear
Mhm,
because he's using like what I see he's using an interface,
mhm,
uh, and I think the adapter is like letting the audio player uses that package,
mhm,
which is the advanced media player.
mhm. Fair enough. Anybody else would like to try it out?
I didn't. It takes some media
Mhm.
and try to adapt it to the advanced media player. I think
Fair enough.
that's
Fair. Yeah,
that's
yeah,
what
fair.
I understand.
Yes, yes, fair enough. Okay, so basically what's happening here is that, we have an audio player device that can play MP3 files only, right? So we have an audio player and it can only play MP3 files. And now you want to, for example, add an additional advanced audio player, which is this one. And so that for the users of this audio player, they can be able to play not only MP3 files, but they should be able to play VLC and MP4 files as well. All right, that's the whole idea behind this whole thing. And now let's look at a bit of source code to understand what exactly is happening here, and then of course we'll come back to this diagram again, and we'll have a bit of discussion as we always do. So first of all, you have something called media player, right? Which is your uh, this interface, and then you have another interface called advanced media player. So let's see what's happening here. The media player is basically going to allow you and play. Similarly, the advanced media player will allow you to play VLC files or MP4 files. This is by default going to allow you to play MP3 files, right? Or basically, it just plays. You tell him the file name and the type, and it will play it for you. Now, what's the implementation? We'll look at very shortly. So let's look at this VLC player, which is implementing the advanced media player, and it will say, okay, we will be playing the VLC. Similarly, the MP4 for player will play an MP4 file, for you. Of course, don't worry about this. This probably is violating one of the solid principles, but that's not the aim at this stage. So what we have done so far, we have done what? We have created a media player which allows you to play, and we have advanced media player which allows you to play either a VLC file or an MP4 file. So far, so good?
Yes.
Yes.
Okay. Now, let's look at these files now, and let's look at this adapter class, which is basically, the adapter design pattern. In this case, this is gonna be the media adapter. Okay, the media adapter. This is our adapter class, which comes as a result of the adapter design pattern. Now, what it does, basically, what's happening here is that as part of its constructor, you tell him what kind of media you want to play. And if it is a VLC, it will go and create a VLC player for you. If it is an MP4, it will go on and create an MP4 player for you. And accordingly, when you're going to call the play method, if it's a VLC, it will go on and play the VLC file. And if it is MP4, it will go on and play MP4 file, right? No. We're done with this adapter as well, which is actually the adapter class coming in as a result of the adapter design pattern. Now let's look at the audio player and what's happening there. Now in the audio player, we again have something called play, and it does what? It says that, if you're looking for MP3 files, I'm going to go and create MP3 files. Otherwise, if you're looking for VLC or an MP4 files, I'll do what? I'll call this media player adapter, right? And I'll pass on the file type it wants to be played, and then it will take care of it. So basically it will go on and somewhere here and it will come to the play, and then again if it will be VLC, it will go and play VLC. If it will be MP4, it will go and play MP4 file. Is this point clear? That what's happening here in the audio player?
Yes.
Right. Now, lastly, let's look at the demo class, what's happening here. So from a demo class perspective, it will only go on and create an audio player. And if we'll say, I want to play MP3 file, I want to play MP4 file, I want to play VLC file, some other format, so on and so forth, right? So from a demo class perspective, it's only calling audio player and it's telling me, play me these files, right? Now, in case of MP3 file, it's able to do it itself. So it will just go on and play it for you. In case of request of an MP4 or VLC or some other format, because it cannot do it, it will go on and ask the media adapter to go and play it for us. And of course, the media adapter will do what? It will go on and create that specific file.
Doctor,
Yes, please.
I have a question. Why
ahead.
didn't you implement the media player with the VLC player and MP4 player directly?
So why I didn't implement the VLC and MP4 here, right?
With the media player, yes.
With the media player here, right?
Directly, yes.
Yeah, something like this, right?
Yes.
Now, and this leads to another question, which is, and I was hoping that we will have this question, is how this is different, how adapter design pattern is different from a decorator design pattern. What do you think, guys? Because what was happening in a decorator design pattern? You had a functionality, right? Let's say you have an audio player functionality, right? And then you wanted to add MP4 and MP3 or VLC functionality. So basically, you can go on, as you're saying, create this media player and extend it, or maybe create a decorator class and extend it, right? And use it. See, the key point here is adapter allows you to connect or combine, independent subsystems or packages. So basically, this is the original one. You have another subsystem or a component or a piece of code which is already there for you to go on and play VLC and MP4 files, right? But they are not able to communicate directly because they are incompatible or they are independent. In this case, they are independent. So basically, you're creating a media adapter which seamlessly, from a demo perspective, it's seamless. That it will seamlessly go on and adapt the request of an MP4 from here to here and get back and play it for you. So you will not be creating these direct relationships because they are separate independent components or plugins. And you're using this media adapter to combine or connect the one type of subsystem with another type of subsystem with the help of this media adapter, like the hardware adapters. Did I answer the question? Is it clear?
Could you please repeat just the last point?
Okay. Okay. Now let me talk about the adapter first, then I'll compare with the decorator. Now, the aim of adapter is what? Let's come back here. The aim of the adapter is what? It's a design pattern which involves an adapter class which will be responsible for joining the functionalities of independent interfaces. In this case, the example I'm showing you is independent interfaces, right? So you're trying to join the functionalities of independent interfaces. So basically, we have an advanced media player and an audio player, right? So this advanced media player is a separate functionality. It's a separate system, a separate piece of code. And you have a normal traditional audio player which is able to play media MP3 files. You want, from a client perspective or a demo perspective, a seamless integration that, from here he will be able to request any file he wants to play. And under the hoods, if it is MP3, I'll play it myself. It is MP4, I'll go through the adapter and get it to play from this piece of the code, which is a separate independent code.
Yes, I got it. So it's to easy connect any other external systems that would support the same purpose of the system.
Exactly. Now the question is how it's different from a decorator. Because in the decorator, we said that we don't want to change the structure of this existing system while we want to add new functionality. Here, we're also adding new functionality. So you can argue with me and say, why didn't we use a decorator here?
I really don't currently don't recall.
Decorator, right?
Yes.
The decorator, let me say it again. The decorator was that if I want to add a new functionality and I don't want to change the structure of the existing one, right? I can go on and create a decorator class. So in this case, one can argue with me and say, audio player, MP3 is there. I want to add MP4 and VLC. It's a new functionality. I don't want to change the structure of the original one. So why not I use decorator? Why I'm using the adapter here?
Maybe, I don't know, but maybe for the decorator, it's, I don't know, maybe it's, no, really, I don't know.
Go ahead. Yeah, go ahead.
I said like maybe it would, it's part of the system. It's not like another external system.
Jazakumullah khair. You're spot on. Right? Because if these new functionality you're adding is part of your system, then yes, go ahead and use decorator because you're adding a new functionality without really need to change the structure. Here, the idea is that if you are coming across an application where you already have an existing external or internal subsystem, and now they are not compatible or they are different and you want them to work together. So this is not part of your you're not adding that functionality into the, or you don't plan to add that functionality here in a sense. It's just external to you. So basically you can use adapter design pattern. Is this clear to everyone?
Yes, at least for me.
All right, so it's basically, it's just the aim at which you're trying to do. What exactly you're trying to do? What's the name of your application? Any questions on adapters, guys? Can I be confident here? Some show of hands will give me a bit of confidence here, if everybody got the idea.
Doctor,
Yes, go ahead, please.
and this seems like it's not good design because we put two purpose in the audio plays instead just one. Focus on one.
This one or this one?
The audio player that we
The
call
audio player, yes.
that it use a media adapter.
Jawad, can you say the question again? I lost the voice there somewhere.
I say if this design evaluate with the SWE design, the S that
Yes, yes,
audio
yes, yes, yes,
play
yes,
have
yes, yes.
two purpose.
So does it violate the solid principle, or does it violate the single responsibility principle, right?
Yes, that's
Yes. For the audio player?
yes for audio player.
Yes. Now see, if you look at this functionality, it's only doing one functionality, which is basically play, right? So it's only responsible for one part. Now, of course, within it, it's calling different, using other ones, which is okay, because this is what will happen anyway. The clear violation actually is, as I said, and we're going to ignore it for the time being in this example. The clear violation here is actually that you have an MP4 file where basically is doing nothing. It's like, override and it doesn't do anything. Or here you have VLC, which doesn't do anything. So this is kind of violation, but that's not the focus at the moment, right? So, but does audio player violate the solid principle? I think it's doing fine because it's actually, just has one functionality, which is to play. Okay. Are you comfortable, Jawad, with this?
Okay, that's fine.
Okay, great. Now, let's move on to the next design pattern, which is a bit different from the first, three we have seen. So far, how many design structural ones we have seen? The facade, the decorator, and the adapter, right? So we have the fourth one, which is our proxy design pattern. What a proxy does, it does what? It's an interesting one. It does what? It says it's a class that represents the functionality of another class, right? In other words, what we do is we create objects having original object to interface its functionality to the outer world. So we create a class which becomes available or visible to the outer world while we mask the other one from the outer world, right? I'll show you an example very shortly and hopefully this will become clear. Take a moment to have a look at this one and see what's happening here. And then we'll discuss as we always do. Okay, guys, what do you think? What's happening here?
I didn't get it.
That's okay. That's okay. Anybody else would like to volunteer if you got a hang of what's happening here?
I believe that the proxy pattern demo asks the proxy image for like certain functionality, okay? And then the proxy image asks the real image about it. He doesn't communicate directly with the real image.
Correct, correct, correct. And we have something called load from the disk functionality here, while we don't have that from here, right? So let me explain this one. See what's happening here. That we have a real image class, a concrete class, and this real image concrete class helps us load image from the disk. So let's say we have a database here or a file or whatever we have here, right? And the outside world, which is this one, right? They don't communicate directly with the real image. We don't allow that. Basically, what we do is we say to the to the outside world, go on, and you will be able to create or access the proxy image. And within the proxy image, we will do the functionality that if the object is not available, we will go and create this one. If it is available, we'll just return it. So let's look at the source code, and then we'll come back to this slide again to better understand what exactly is happening here. Now, so we have this interface called image, and basically just nothing but just signature. You to first have a look at the top one with me now. Okay, so ignore the bottom one for the time being. So what exactly we're doing here? We have a private file name, right? And then we're passing this file name into our constructor, the real image constructor. And it does what? It goes and loads something, loads that file from the disk, right? And this load functionality is somewhere here. Again, it's private, and it will go on and, for example, read from the database or read from a file and so on and so forth. Is this clear to everyone, this part?
Yes.
Right. Well, let's look at the proxy one. So proxy one is doing what? Again, it's creating a private object of real image, and of course your file name. And now when the constructor is called, it says, okay, file name. Then when it comes to display, it says that if this image is not object is not available, if this real image object is not available, it will go and create the new real image, which will basically call the real image. Which is basically, this one, sorry, on the top. So it will just call this constructor, and it will go and load it from the disk and return the image for you. Otherwise, if it's already there, what will happen? It will just go and call the display functionality.
It's kind of protecting the system itself or the storage of the system.
Correct. Absolutely.
And also reducing or increasing the efficiency of providing the image.
True. Absolutely. Absolutely. You're spot on. Spot on. So if you look at the demo now, what happens there? Basically, you say, I want to load a certain image. It says, okay, and I want to display it. So if is already, for example, let's look at this. If it's already not loaded, it will do what? It will go and this image.display. It will go on. Image is basically a proxy image. It will come here. It will say, you want to display it? If the image doesn't exist, it will go on, create the real one and load it from the disk. If it's already there, it will just go and display it for you. All right. So as you guys mentioned, identified it, from an outside world, you are not allowing them to directly access your storage, probably, right? And at the same time, you're getting a benefit of maybe having a faster performance, because you do not need to go and load it from the disk or the database all the time, right? So far, so good. Everybody got this one?
Yes.
Yes.
Yes, sure.
So it's a lot of benefits here. Now, Let me just very quickly refresh your minds and relate these things now, right? Do you remember that famous diagram I showed you in the beginning, which I refer to sometimes again and again, where we said that, we'll have a design patterns at a very low level details, right? And then we have the architectural styles, right? Remember that
Yes.
diagram? Right.
Yes. Remember.
So
Yes, yes,
basically,
Victor.
yes, and then I show you another diagram which was very even before this one, which was basically, when you have the requirements, we do design at two levels. We have design at an architectural level, and we have design at a detail level, right? And of course, the architecture also influences it, and so on and so forth. So all of these decisions actually, that, for example, you want to mask this layer from the storage, probably are taken somewhere here, right? Like you say, I want to have a layered architecture, right? And I don't want the outside world to be able to access the database directly. So these are somehow being reflected in your detailed design, and you can use some of these design patterns to help you achieve it. And so is true for other design patterns as well, that you can structure them in such a way, or you can create the what you call uh, the structure of your class diagrams, the detailed classes to reflect your architectures, and they all help and go together in a system. Okay, are you able to now fill the or connect the dots now? That this is what is happening. That you take decisions up here, then they are reflected into detailed design and how you achieve it. You have different, so for example, in this case, if you want to look for layers, probably proxy design pattern will help you achieve that. Cool.
Yes.
Cool.
Any questions on this,
Doctor,
guys?
yes.
Go ahead.
But I thought that the architectural design and decision is more of organized. It's not. It does not depend on the code more than. Yes.
Okay. Now, this is exactly what I'm trying to connect the dot now, is that, when you take a decision that I will have different layers, right? Right. So,
Yes. Yes.
so when you take those decisions that I will have a layered system, eventually that decision needs to be reflected in your detailed design, right? So when you take a decision, then it still needs to be reflected in your detailed design, which actually will be eventually reflected in your source code.
Yes.
Okay. And so if, for example, you take a decision here that it will be layered, then in the code, it has to be somehow layered. That
Yes.
this part should never talk to the database directly, for example, right?
Right. Yes.
So they go hand in hand, and actually, that's why they are at a different abstraction level and different level of details. But eventually, this is one system you were talking about, and there is no system without a source code.
I see. So if we take this as an example, so we'd consider the proxy pattern as, for example, as the interface for the user, and the one in the middle is like the logic, but it's in a small. And
Yeah,
the
true.
last one is like the database. Is the same thing? Or?
Yes, yeah, absolutely. Like if this, for example, this was such a small system, that is what we're exactly doing.
Yes, I get it now. Thank you.
Cool, alhamdulillah, perfect. So I think because alhamdulillah, we're coming to that stage of the semester towards the end anyway. So I think the dots are now starting to connect as well, and inshallah it will become more and more connected as we move towards the final stages of the semester. So I believe everybody is comfortable with the proxy one, right? It's not that hard, isn't it?
No, on a small scale at least.
Yeah, inshallah, and even on the larger scale, it's not that difficult, to be honest. It's just that as long as you know the concept, it will work.
Yeah.
Okay. Now, this brings us to the last design pattern I aim to cover on a structural side for us, which is called the bridge design pattern. Now, I like your special attention for this one because this is a bit harder to understand in the beginning. as compared to the other fours we have seen so far. Okay. So, and inshallah, we'll do an activity for this as well. So, special attention for this one now. Bridge is used when you need to do what you want to decouple the abstraction. So you want to decouple the abstraction from its implementation so that the two can vary independently. So this is allowing us to decouple the abstraction and its implementation. In other words, what we are doing is we are decoupling the implementation classes and the abstract classes by providing this bridge structure or this bridge interface class, which is the design pattern. So basically, we're going to decouple the abstraction from its implementation. In other words, basically what we'll be doing, that we'll be creating an interface which will act like a bridge on the river or sea, like a Bahrain bridge, causeway. So basically, this bridge pattern says create an interface which will act like a bridge, which makes the functionality of the concrete classes independent from the interface implementer classes. Okay, it decouples abstractions from implementations. It decouples the functionality of the concrete classes from the classes which implements the interface, and basically this interface is actually nothing but a bridge. Now, both type, as a result, what will happen? I'm just going to go through at the moment and I'll come back to this slide again as I usually do to connect again the dots. So basically both type of classes, the concrete classes and the classes which are implementing the bridge, now can be structurally altered without affecting each other. So you can go on and structurally change them. Let's look at an example here. So let's say we have a circle and we can draw this in different colors using the same abstract method but different bridge implementer classes. Take a moment to see what's happening here before I explain this one in detail. And kind of look at these ones, focus on these parts. Take a moment to have a look at this one. Yep, anybody like to go ahead and see what's happening here?
Doctor, I have a question.
Yeah, go ahead, please.
Does draw API implement or inherit shape or what? How it's used?
Okay, it will actually, we'll see, very shortly, we'll see.
Okay.
So the demo class, actually notice a demo class is not directly talking to the circle here, right? It's not using the circle at all directly, right? So in this system, what we're trying to do is we have a certain shape and we want to draw that specific shape. In other words, we want to draw a red circle or a green circle. And we have created something called draw API, which is basically which will act as a bridge. So this will act as a bridge, and then we have an abstract class called shape. So what we are trying to do is basically decouple these two parts. How? We'll look at this now and then we'll come back again, okay? So let's start looking at the source code. Hopefully this will become more clearer. So first of all, let's look at this draw API, which is our bridge, right? So basically it will do what? It will allow you to draw circles. So it will take as a parameters radius and X and Y values. So you're able to go and draw API. And then you have these concrete bridge classes, which allows you to go and implement it. So basically, red circle does what? It takes these 3 parameter values and it goes on and prints this line or something like this, that this is the radius, this is X and Y value. Similarly, the green circle again implements the bridge API and goes on and does the green drawing of the green circle for you. So far, so good.
Yes.
Okay. Basically, we have a bridge API interface, concrete classes. They do nothing but actually give you the functionality of these ones. Now let's look at the shape abstract class and see what's happening here. So we have an abstract class called shape. See what's happening on this line.
He's creating
No, it's only used
draw
for
API.
the package.
Say it again, please.
Used for the package, right? And inherit the child's classes.
Yes. So basically, it will say it's doing what? It's using it, right?
Yes.
In other words,
yes, it's initiating a draw API package object. I mean.
Yes, yes. Which actually at the end will be red or green at the end of the day. Right. So basically, it's doing what? It's saying shape draw API. All right. And of course, it has an abstract method called draw, which will be implemented in our circle concrete class. So basically, you will have a draw API here. So it will again go and draw the circle here, right? And in the constructor of this concrete class, what's happening here? Say, give me the object you want to draw, right? It's radius X and Y, and it will go on and create an object for you. Is this part clear? Is these two parts clear?
Yes.
Okay. Now, so basically what we have done so far, is that we have a draw API bridge. We have the red circle and the green circle. We have their own original functionalities. Now we have an abstract class shape. It basically does what? It goes on and creates or uses the draw API. And then we have this concrete circle, which actually allows you to create a circle object and go on and draw it. Now, let's look at the demo and see what will happen here. What is happening here now in the demo? Demo, first of all. Yes, go ahead, please.
Yes, it's drawing either a red circle or a green circle using it's using the circle, I thought.
So basically what's happening here, it's saying go on. So basically this is what is happening here. It's actually going and drawing the red or the green ones, right?
Yes, without initiating
the circle. It doesn't take the circle at all. See, there's no use between it. So it just goes directly and says, go and draw me a red circle or a green circle, right? So it says, okay, you want a red circle? At the end of the day, red circle is a circle, right?
Right.
All right. So basically, what happens here is that you pass on these values and new red circle to the circle object, right? The constructor here, right? So it says, give me a red circle.
But Doctor, if like have many colors, what will happen? Like, would you do
exactly. Many lines, actually, right?
Yes.
And of course, they go on and draw this one and this one and so forth. Now, let's have a bit of discussion here. What exactly is happening here now? Now, how it has decoupled? That's my first question. If you read this line, I was saying what? The bridge is used to decouple the abstraction from its implementation. In other words, I was saying that you will create a bridge interface, and this will make you decouple or have the functionality of the concrete classes independent from the interfaces implementing the classes. In other words, both of the classes can be altered structurally without affecting each other. How this is happening here?
Could you repeat it again, Doctor? The last point, yes.
Yeah.
This one, the functionality about the function.
Yeah, so we said that the both types of classes can be altered structurally without affecting each other. Right? Is this happening here?
I believe yes, it's happening here because we have created interface draw API and using it to create red and circle and green circles without affecting the shape itself.
Exactly. So basically tomorrow you can go on and add green to, can go on and add yellow, right? And so on and so forth, right? It will have
Yes.
no impact on this part.
Yes.
And
So
similarly, you can even add rectangle here, right? Or triangle or so and so forth. It will not impact any of this part.
Absolutely.
But Doctor, if, for example, extend rectangle,
Yes.
I have also to use like red rectangle and green rectangle and so on.
If you need to.
How? Like I don't see I could use red circle with the rectangle.
Yeah, absolutely. You cannot, right? So the idea here is what? The whole idea of this design pattern is what? That you want to structurally, this is, remember, a structural one, right? So you want to structurally separate them. You want to structurally decouple the abstraction from its implementation, right? So what is an abstraction here? Abstraction is that you have shapes, right? So you have circles and rectangles and triangles, while the actual implementation is what? You have a red circle, a green circle, a red rectangle, a yellow rectangle, so on and so forth, right?
Right.
So you want to structurally separate these two parts.
I see.
Right? And then you can go on and change this one without impacting really this part, or you can go on and change a yellow circle without really impacting the rectangle or any other parts.
Right.
So it's already 10:50. So is this bit clear? Inshallah, we'll do a class activity on this one. Inshallah, I know this is probably the hardest of the structural design patterns.
Doctor, it's clear, but like
when to use, huh? How to use
yes,
it, huh?
yes, when to use and how and
exactly. No, I will very quickly, though we are out of time. Let me take the attendance and so that if someone has to leave, he can leave, right? Yes.
Doctor,
Yes, please.
I came late because my laptop was updating the Windows.
No problem so much. Don't worry about it. Inshallah, should be all right.
Okay. Thank you.
So you guys, if you have to leave, you can leave, but I'll just answer this one very quickly. Yes, look at this one, right? Remember there was another one on the top, which was the domain one, right?
yes.
Do you recall that one, right?
Yes, the enterprise something.
The product line. The product line.
Yes.
Right? The product line, right? Now, inshallah, if I have time towards the end of the semester, inshallah, I'll give you a lecture on that. But see, what will happen here is that in a real world, companies make different products, and those products, have some common and variable functionalities, right? So, for example, you are making a an operating system, for example, or for mobile applications, and then on top of that you have applications which are basically some of them have different kind of camera filters, and some of them have different kind of what you call FaceTime functionalities and calling functionalities and so on and so forth. So you might try to separate the abstraction from its implementation so that in a given system you can activate them and deactivate them, include them and exclude them and so on and so forth.
Yes.
Now, inshallah, I'll give you a class activity on this, inshallah, on Sunday, and hopefully this will become even more clearer, inshallah ta'ala. Inshallah ta'ala. So I'll stop the recording here.